Greetings, Patriots. Please take an opportunity to set yourself up, take out your guided notes. We will be creating a representation of a relation or a function in multiple ways by using a table, by looking at a mapping diagram and a graph of the same relationship, okay? So you're going to have an opportunity to identify the characteristics of a function or not a function in different representations. So let's go ahead and take a look at this first item here. I've given you a set of ordered pairs, and remember, as I've stated before, color is really important here. I like to use my pink highlighter to represent my x values. So if I look at this relation, I have -2 paired with a 3, -1 paired with a 4, 0 paired with 6, 1 paired with 5, and 2 paired with 4. Okay, and I can see once again that my x coordinates here are not repeating. So that's a nice indicator that I am going to, this relation, let me write this down. These x coordinates, I'm abbreviating that, are not repeating. So this is a nice indication that I have a function here because every x coordinate is going to be paired with one y value. And I like you all to look at that. There's no duplicates, right? There's no repeaters. Okay, and we've talked about this a little bit in class, how when x, right, is assigned one and only one y value, we have a function going on here. There's no duplicates. I don't have any cheaters here. No duplicates in the x values, okay? No repeaters. So what I'm going to do now is I'm going to take that ordered pair and represent it in a table. -2, -1, 0, 1, and 2. I'm going to match up the y values. Oops, using my yellow highlighter. My y values are in yellow, my output values, and I'm going to go ahead and write those down. -2 is paired with 3, -1 is paired with 4, 0 is paired with 6, 1 is paired with 5, and 2 is paired with 4. So here you can see once again that I've taken a set of ordered pairs and represented it on a table, which all of you should be able to do. The characteristics will be the same. Again, your x coordinates, only focus on your x. Your x coordinates are not repeating themselves, so this is a wonderful indicator that we have a function because our x coordinates are not repeating and they've been assigned only one y value. Now we're going to take this same relation and we are going to map it using our mapping diagram. So take your -2. I'm going to put these -1, 0, 1, and 2. You can actually type those if you're using your Google Slides. And then I'm going to go ahead and list my range values of 3, 4, 6, and 5. So again, these are your domain values, right? Your y values, and these are your, oops, Miss King just made a big mistake. Ignore what she said. Sorry, your domain values are your input values, your x values, and I listed those in order. My range values are the set of all my y values, okay, range. All right, so now when we map, we have to actually map these out. Remember, we're drawing arrows to see who -2 is paired with, and I know according to my ordered pair, -2 is paired with 3. -1 is paired with 4. Again, I have one arrow coming from -1. 0 is paired with 6. One arrow is coming from 0. 1 is being paired with 5. So one arrow coming from 1. And 2 is being paired with 4. Again, one arrow is being coming from 2. So therefore, every element of the domain is paired, right, or traced to one and only one element in the range. So I'm going to make that note that every input value, every x value is paired with one y value. And one way to always look at a map is to look at the arrows that you're drawing, right? So what I love about this is one arrow, right, is going from the domain elements, the elements in the domain, from the domain to your range values. Okay, only one. Some people will say, well, wait, there's 2 arrows pointing at 4. Yes, but from each different domain value. So -1 is paired with 4, 2 is paired with 4. That's okay. They can share the same y value. But there's one arrow going from the elements of the domain to the elements in the range. Last but not least, go and plot your points. So when you look at a map, that's one of your characteristics. Look to see how many arrows are coming from the domain values. Okay, let's go plot in our graph. So I'm going to take this same relationship, -2 is paired with 3, -1 is paired with 4, 0 is paired with 6. Go ahead and plot your ordered pairs. 1 is being paired with 5, and 2 is being paired with 4. Okay? So again, every x, right, is assigned one y value. So what we're going to do is we are going to take this and we are going to draw a vertical line and test it. That's our characteristic. That's one of our strategies. So let's draw a line, and do I only intersect at one point? Every time I draw a line, am I only intersecting at one point? So when your vertical line test, so your vertical line intersects at one point, you have yourself a function, okay? 1 point of intersection. So our final is to look at the characteristics of each of those representations and ask ourselves, is this relationship a function? Using your definition of a function is a special relation in which every x value is paired with one and only one y value. So based on the information that I've been given, I can state that this relation is a function. Is a function. And you can type this or write it, because each x value, each of those input values, right, is paired with only one, and I'm capitalizing that, y value. According to our definition, this is true. Y is a function of x. Okay, make sure you take good notes. Now we're going to do one additional example. Example 2. In this example, you've been given a mapping diagram of a relation. So what we're going to do is we are going to take that and we are going to write it as an ordered pair. So as you can see by looking at your mapping diagram, 0 has been assigned to -2. 0 also has a second arrow, and that's been assigned to 1. Then I have 1 has been assigned to 2, and sometimes it might help to use color here. 1 has been assigned to 2. 2 has been assigned to 1. And 3 has been assigned to 4. So when you look at the following, go and highlight your x coordinates. And thinking about the definition of a function, see if every x coordinate, does it have a repeating value? And has it been assigned only one y value? I'm sorry, Patriots, I had to stop, so let's come back. I had just taken from the mapping diagram all of the ordered pairs and asked you all to highlight all of your x coordinates. So if you take the opportunity to look at the x coordinates, you can now see that the x coordinates are repeating. There appears to be a repeater there. So if I look at my x coordinates, I can see that 0 is assigned two values. So according to my function definition, which is at the bottom of your page, your x-coordinates, okay, according to the definition, your x-coordinate can be paired with one and only one y value. The x-coordinate has a repeating 0, so that tells me that because there is 0 twice in the set of ordered pairs, it has been assigned more than one y value in this case. So there's that duplicate, right? So therefore, that is a characteristic when looking at your ordered pairs. I can take those same ordered pairs and place them in a table. So 0 has been assigned -2, 0 has also been assigned 1, 1 has been assigned 2, 2 has been assigned 1, and 3 has been assigned 4. And once again, I can see that same x input value of 0 being assigned a -2 and a +1. So therefore, that goes against what the function definition says in regards to x values can only be assigned one and only one y value. Okay, so let's go ahead and take a look at our graph representation. I can plot those same points. So when x is 0, I can see that it is assigned -2 down here, but it's also assigned a +1. So I technically have two values that 0 is assigned to. 1 was assigned to 2, 2 was assigned to 1, and 3 was assigned to 4. So as I plot my ordered pairs, this is what my graph would look like. Once again, if I take my vertical line test like I did in the previous example, and I go through when x is 0, it is intersecting at not 2 points, not at 1 point, but at 2 points. You can see there are 2 points where that vertical line intersects, which again lets you know that 0 has been assigned the value of -2, the range value of -2 and +1. That is why that vertical line is intersecting at 2 points. So when that vertical line intersects at more than one point of intersection, it is not a function. So the vertical line test actually fails here, I guess you want to look at it that way. Vertical line intersects two coordinates when x, the element or the x coordinate is 0. Okay, so therefore it intersects two coordinates. That means it is not a function. Again, you can see in your mapping diagram as well that the element of 0, right, an element in the domain, so the element of 0 in the domain, or just using my vocabulary, is paired with two values in the range, is paired with two elements or two values, right, in the range, which is the set of all y values. And you can see that because, and I'm just going to highlight this in blue, from 0 you see two arrows coming from 0 to -2 and +1. And remember, in a function you can only have one arrow, so that 0 is what is messing it up. Okay, so is the relationship a function? I have to now say that this relation is not a function. Please make sure you write that. This relation is not a function. Why is it not a function? Well, once again, because the element of 0, which is found in the domain, is paired with two elements in the range. You must justify in writing two elements, in the range. Why this relation is not a function, and that is why. And just for justification, can you write those ordered pairs? 0 has been assigned -2, and 0 has been assigned +1. So this relation is not a function. Why? Because the element 0 in the domain is paired with two elements in the range, and that's your justification as to why example 2 is not a function. You will be given a specific relation, and you will have to determine whether or not, based on what you're seeing, either in an ordered pair, a table, a mapping diagram, or a graph, and you will have to justify whether it is a function or not a function. Don't forget to use that definition that states a function has every x paired with only one y value. Have a great day, Patriots.